and welcome into this event, The Future of Logistics. Great to see so many of you here already online now on the early morning. Let's make this event open, collaborative, and interactive. Although we have two excellent guest speakers here from the industry, Lauri Impiö from SSE Schäfer, as well as Timo Husso from Konecranes. I believe that this is also a good opportunity to discuss these topics. So you have an opportunity to have questions and comments here on the chat, as well as by raising your hand, so you can also participate the discussion. However, I think that we can keep our cameras and the microphones off when we are not speaking. Sorry, misspelling there on my text. Microphones off. Yeah, but so you are also allowed to join this discussion, and in that way, let's make this even more fruitful for all of you. And I believe it will be easier for our guest speakers to present their ideas if we have questions and comments after their presentations. We will also publish some highlights and materials after this event in our website, so you will get some follow-up regarding the content. This is actually our first webinar on this concept. We planned this mostly for students in higher educational institutions. As said, this will be a biannual event. We will have also every 6 months that kind of event, and with different content for different focus, also for second level students later. We also believe that this is a good opportunity for business people to join, as well as teachers and researchers, to discuss these future trends and concepts and so on. So let's enjoy this event and make this beneficial for all of us. We, as a LIMOWA, we are an industry-led, not-for-profit and neutral logistics development association here in Finland. We are also participating in international projects. We are focusing on logistics nodal points, so these logistics centers you are seeing here in the middle of the picture. This means that we are working both in transportation system as well as in intralogistics issues. And today, our key guests and professionals will present issues, particularly from intralogistics. Lauri starts from the future of warehousing, and then Timo will add on and particularly focus on the production logistics side. I will try then to summarize those speeches and link them into the Industry 5.0, as well as in the future of transportation system, which we call the physical internet. As LIMOWA Association, you will see also our contacts. We are working with sustainability issues, e-commerce, digitalization, and automatization. We are running R&D projects together with universities and companies, and so we are working in supply chain issues, but because we cannot handle everything, we are focusing on this logistics nodal point. And hope that this presentation, the future of intralogistics or future of logistics, might present what is really going on now in these topics. So I think it is now time to invite our first keynote speaker, Lauri from SSE Schäfer, to tell his experiences and opinions where the industry is going just now. So, Lauri, please, floor is yours.
Thank you, Heikki. Good morning, everybody. I hope you can hear my audio, and Heikki, maybe you can confirm
Yes.
soon if you can see my presentation.
Yes, we are hearing and seeing you well and your presentation.
Thank you. So, good morning also from my side, and thank you, Heikki and LIMOWA, for invitation to participate in this webinar. And I have created a short presentation about the future of warehousing, and as Heikki explained, we will run through the presentation, and after that we will have possibility to discuss and can ask questions about the subject. Hopefully not too hard questions, that I can answer them. A few words about myself. As said, my name is Lauri. I'm working at SSI Schäfer. Been in the industry for quite some time. Let's say been working pretty much with some sort of automation since graduating in 2010. Since this is an webinar targeted to students, I added also my own education background in this slide. So I'm a Bachelor of Mechanical Engineering from 2010, and then while working, I also did my MBA in 2022 in International Sales and Sales Management. By the way, if you want to follow more intralogistics content in LinkedIn, you have the QR code there on the right bottom corner. So by scanning that, you will get to my LinkedIn account, and then you can hit either connect or follow as you wish. Great. So my presentation, I have divided it in 5 parts. First, we will take a short look on SSI Schäfer, what our company is about, how do we operate and where. Then I prepared a short section about generally why warehouse automation, why do we need warehouse automation. From that, we will continue to take a look of one case example of a future warehouse. Then we talk shortly about AI in warehouse automation, and to conclude, I have a short section about top skills that I think are important for future warehouse professionals. I don't know if it can be somehow. Oh, we have the recording on. So SSI Schäfer, if you know what SSI Schäfer is, or have seen our equipment, or even better worked with our equipment, you can hit the thumbs up button or some reaction in Teams just to get an overview. Is there how big of an audience we have here who has worked with our equipment? Some reactions there, so at least some already might know a little bit about us, but I will not spend a lot of time describing our as a company, but maybe focusing more on what we are doing in the field of intralogistics. SSI Schäfer, we are a German-based family-owned company, been in the business for almost 100 years, founded in 1937. We are a company that has roots in manufacturing, steel manufacturing, and roughly from the 2000s, we have shifted our focus into automation. And that has been done both by just growing in a neutral way, and then by purchasing different companies to be part of the SSI Schäfer group. And nowadays we are a global company of approximately 9,000 people. We work basically in all continents. Of course, Europe is our home base, as you would say it, but we are fully focused also, especially in the North Americas and in Asia. We have 7 production sites, and in Europe we have our headquarters in Germany and Austria. So what do we do in intralogistics actually? We have quite a broad product portfolio, which this picture gives you, let's say, an overview of what we can deliver and what type of projects do we work on. It all starts from manual storages. So what probably many of you know, like how a manual warehouse looks like. There's some pallet racking or shelves for small parts. This is something that we manufacture. We have our own steel manufacturing in Germany. And this is, let's say, one part of the business. So we are producing equipment for manual warehouses, whether it's racks, shelves, plastic totes, whatever is needed in that context. And from moving from that manual context into a more, let's say, semi-automated context, we have products like mobile racking, vertical lift machines, AGVs, which are then kind of moving more towards an at least somewhat automated storage. And then even, let's say, moving forward from that, we have then a lot of technology for building completely automated warehouses, whether it's automated pallet storages, small part storages like shuttle systems, of course, conveyors, things like that. And as in this picture also, what kind of then connects all of this together is the software part. So we have our own software family with a brand name WAMAS. And with that software family, we are producing, let's say, all levels of software required in warehouses, starting from simple warehouse control systems, ranging all the way up to full BMS systems. Here is a short overview of some of the companies that we work here in the Finnish market, where I am based. So I am responsible for our sales activities here in Finland. We have a small sales team of 4 people here in Finland. And here are some of the key customers that we work with in Finland. So, warehouse automation. Why do we need that? Of course, there's a lot of reasons, and you could create a long presentation explaining why somebody needs warehouse automation. But I took more of the angle here that what are those mega trends that are really driving us and the companies towards warehouse automation. And now this is more even from the Finnish perspective. So if we think from our local Finnish perspective, one of the key drivers is labor shortage. So simply put, nobody wants to put these gloves on, or less and less people want to put these gloves on anymore. So we have big generations that are retiring, those generations that have been accustomed to working on with their hands. That is creating a difficult situation for many industries to replace those people who are retiring. Especially when we're talking about physically demanding roles, working in shifts, it's not so easy to recruit, and you don't have to go far from the capital area that the companies are really having difficulties to finding good employees for logistics roles. And third, and the last point is that when you find someone, they are also quite quick to leave. So it is a really tough situation for many companies at the moment in the labor market. Second trend that is driving the warehouse automation is the delivery trends. This is a global phenomenon. Of course, it's not just for Finland, but we have a situation where if we go back 10, 15 years, if you ordered something online and somebody would have said to you that you will get it in 3 days, people would have been like, wow, that's fast. But that terminology has changed, and 3 to 4 day delivery is no longer fast. And we can see this from international players like Amazon, how much they are putting effort in this same day deliveries within X hours. And in Finland, we have, for example, verkkokauppa.com that is putting a lot of effort in these quick deliveries with Wolt. And kind of it's an development in a sense, but what makes this really difficult for the companies is at the same time approximately 70% of the consumers they're not really willing to pay for that. They want to choose the way that is the least expensive for them. So this is really putting a lot of pressure to companies on how to develop their warehousing, picking, dispatching, the whole automation to be more efficient and quick in their order picking and order processing. Lastly, but not leastly, this is a little bit of old information, but I think we can all relate to this, that when the COVID pandemic hit us from 19 to 20, we had a 33% leap in the Finnish e-commerce market share. Earlier, the market had been growing with a pace of approximately 7% per year, and then we had this huge bump. Of course, the growth has stabilized after that, but I think that really kickstarted this e-commerce trend also in Finland. And of course, this is putting a lot of pressure to the customers how to handle this these growing volumes and how to reply to that demand from the consumers. I hope the videos are playing well over Teams. That is always a small risk, but you have to take some risks. So I have created a couple of slides of one local case example in Finland, a company called Fresh Servant. Somebody of you might know it better than others, but I have some slides where we can look into of an example of this type of futuristic warehouse. Of course, it's a warehouse that is operating already now, but I think it's a very nice example of what is the kind of the direction where the warehouses are evolving towards. This is a project that we realized a couple of years ago, and I think this quote from the CEO of Fresh Servant kind of nicely captures why they went into this project, because Fresh Servant is a food manufacturer and they feel like the food industry itself is in a state of revolution, and it is driven by this ultra freshness. So the consumers want real, like, fresh food, and that puts a lot of pressure into the logistics side. So how can you manufacture efficiently, but after the manufacturing, how can you pick and deliver the products to us consumers as efficiently as possible? So Fresh Servant, it's a salad manufacturer in Finland, located close to Pietarsaari, and they claim to be the most modern fresh salad factory in the Nordics. I haven't done any fact checking or compared. I didn't visit any other factories, but I know by visiting them many times that this is most probably true. They have been growing in a very fast pace, approximately 10 to 15% for many years, and they have created approximately 50 new jobs every year. And it's quite a big number of products that they are shipping to stores around Finland. You will probably know them best by this ready-to-eat salads with this brand Heikki. So, what does their warehouse then look like? I have a couple of slides with some videos explaining a little bit how the warehouse is built. And if we start off, everything is basically connected with conveyors. So they have this empty white totes, as we call transbox in Finland, that we use to deliver food to stores. They are coming, empty totes are coming in stacks from the washing facility, and they are automatically fed to different production lines. And when they have been filled with production, as you can see in this video, the full totes are then coming on this conveyor system, and they are transported into a shuttle warehouse. The actual shuttle warehouse, what you can see in this video, is our SSI QB shuttle system. We have 2 aisles, 4 lifts, 58 shuttles. Maybe the numbers don't mean so much to you, but just to give a little bit of the scale. And we are using it both for storing the full totes that are coming from production, but we are also storing the pick totes that are waiting for dispatch. So the same storage area or the automation is combined storage and a shipping buffer that we use it for both needs. From that shuttle system, we then deliver the totes to picking. And we have multiple picking areas. In the video, you can only see the manual picking, but they have also implemented robotic picking at Fresh Servant. So the most fastest moving SKU stock keeping unit, they are picked by the robots. And after that, when those products have been picked, the totes continue to this pick by light area where the pickers are then picking the medium and slow movers manually. And after the picking is done, the ready totes are then returned to the shuttle system, as I said earlier. So we are using the shuttle system also as a shipping buffer. And when it's time to dispatch and send the products to customers, we release the totes from the shuttle. They are transported by conveyors to robotic palletizing, and then the created pallets are loaded into trucks and transported into stores. Everything in 3 bullet points. And why is this? What makes this so futuristic or good or efficient? Number 1, all of this movements of products which don't actually really create value, they are automated. So the human labor is really limited to the manual picking part and then just overseeing the functionalities and what is happening in the automation. So all of these extra movements between areas, all of that is automated. We have an automated link from production. So the manual labor is really minimized in a good way. Second point, we are utilizing robots for this fast-moving products picking. So products which have a lot of picks, a lot of order lines, they are picked by robots, and then only the medium and slow movers are picked by manual labor. And third point, which is a very important point when we're talking about automated systems, is that it's a clear process, and you can really easily follow the whole process and the big picture through modern HMIs. So you can see what is happening, where is the flow continuous, is there any jams anywhere. So it's very easy to operate and oversee the functionalities. AI in warehouse automation. Okay. This could be a complete presentation of, I don't know how many slides. But of course, AI is yeah, it's everywhere now. People talk about it. But for warehouse automation, it's not very new in a sense. When I was putting this presentation together, I was researching our own documents and I was reading a white paper that we had written in 2018 about AI in warehouse automation. So that's 8 years ago. So I think AI, when we're talking about like industrial use, it has been there for many, many years. Now it's everybody, all us consumers, mostly from launching these large language models, that has really brought AI to our everyday life. And now it feels like it is something completely new and off the charts, but it's been there on the background for quite some time. I didn't go, or I won't go into a very high level of details at this stage for the AI topic. As I said, it's a very broad topic. What we are doing with AI at the moment in warehouse automation, we are mainly focusing on two things, predictive maintenance and digital twin. So in the maintenance concept, of course, our automation systems, they have like maintenance intervals that are predefined that, okay, for example, this maintenance action you have to do every 6 months or every 12 months. And with AI and let's say big data lakes, what we're doing is we are collecting usage information from multiple sites that we are running around the world, and we are combining that data, and we use AI to create these predictive maintenance models so we can really reduce the amount of, let's say, unnecessary maintenance tasks that we are doing. Because at the moment, if the maintenance, and that's been a good model, don't get me wrong, it's like it's better than fixing when something is broken. But if you're just doing some maintenance based on a set interval, you will be servicing all of the equipment with the same interval. If you have, like in our systems, if you have 50 shuttles, the shuttles could have, one of them has been driving for 1,000 kilometers and the other one has been driving for 500. Should they be serviced the same way? Of course not. So with this type of AI modeling, we can really see the individual usage of different equipment, and we can set the maintenance intervals to fit each equipment so that it's not a predefined time-based model. The second one, the digital twin, that is something that we really use already now for optimizing and like creating AI-based simulations. And in the future, we think that this digital twin compared to or combined with AI and data, it will be sort of like a real-time mirror to your warehouse. So you can create a carbon copy which is constantly updating model of your warehouse. So then you can really see and test different scenarios, for example, in your logistics with this. If you want to learn more about the subject, I have added a QR code here. We have a separate company called Supply Brain. It's part of SSI Schäfer that is working with this AI topics. So scan the code and you will get to their website if you want to learn more. So finally, top 3 skills for future warehouse professionals. I think one of the top skills is kind of systems thinking. So automated warehouses, they are systems of systems. So they are built from many different blocks which then interact together. And there's a lot of flows, whether it's like physical flows or data flows between these systems. And I think it's really important for the future professionals, as it is already for the professionals of today, to really see the big picture and see how the systems are connected together and how they interact together, and is there some problems or bottlenecks, for example, in that interaction. Point number 2, or skill number 2, is leading with data, for sure. That is something that is already now a big shift in leadership wherever, but especially when you're working with automation. When you lead with data, it replaces that leading of gut feeling or this is how we have always done it type of leading. So understanding data, KPIs, and then using that information in decision making, I think that's definitely one of those top 3 skills for the future, and as I said already, for today's professionals. Lastly but not leastly, I think it's just the pure technology competence. Like, so you have a general understanding of automation equipment, the software behind it, VMS, VCS, maybe some PLC knowledge. So there's a lot of areas of automation you can have competence on. You don't need to be, professional and specialist in all of this, but you have to have an understanding, again, a little bit on that kind of big picture view, that you have to understand how the system work together, communicate together, and maybe a little bit of like the fundamentals of these different elements of automated warehouses. Thank you. That was my presentation. Heikki, I think you will take the stage, and let's see if we have any questions from the audience.
Yes. Thanks a lot, Lauri, and we have gotten in advance set of questions as well as we have already a few here on the chat. Please feel free also to raise your hand there in the audience if you like to ask or comment them Lauri's presentation. So if I raise
remember, Heikki, only easy questions.
Yeah.
They cannot be too difficult.
Actually, we got in advance questions such as new ways to optimize the process flow. I think you partly covered that part. For example, how to make the processes clear, as well as how to use digital twin. We might come back to these issues after Timo Husso's presentation too. Then we got here questions related to AI, but you also answered in which way you are using them. But if I raise the first here from the chat, here is a question from supplier perspective. How does sustainability and demand from automation users plus end users can be combined best way possible for the future? So sustainability issues related to automation.
Can you repeat the question, please? How can they be combined?
The best way to reach the best possible future. I'm not sure whether I understand this question correctly also by myself, but would you like to comment the sustainability perspective, at least in general?
Yeah, for sure. And maybe as one additional topic for that AI part, because AI is interesting and everybody wants to know more about AI. When it comes to sustainability, of course, in warehouse automation, one of the key topics for us is energy consumption. And we are trying to optimize that our equipment would consume as less of energy as possible. And we have actually, it's a I would say, a development path in AI with our group company Supply Brain, that we are creating this, we call it intelligent energy management. So at the moment, we have equipment in the warehouse which have, let's say, set speeds and capacity, so they work in a different speed no matter what is the required capacity at the moment. So if we have equipment that can do 1,000 boxes per hour, it will work with the same speed even though the throughput would be 100 boxes per hour at the moment. But we are working on a system that would adapt that kind of throughput. So we would adapt the storage to that required throughput at the moment. So we could utilize, for example, slower speeds, slower velocities, which then require less energy. So we can really intelligently manage the energy consumption of the automation by utilizing AI models to optimize that required capacity at that or any given moment in the warehouse.
Great. The second question might then combine these AI issues and energy. So as warehouse and logistics system became more dependent on AI-driven automation, what if the system fails, especially in Europe where energy has been an issue? So what if the system fails, and particularly for if AI-driven automation fails, and this might relate also to the lack of energy. Do you have some backup there?
At the moment, I think the AI, the role of AI in warehouses, it's not like, it's more of an, like, it's used in pre-planning and, like, as I explained, planning in the maintenance task and maybe that we can have, like, on the side of the actual warehouse, we have a simulation model where we can work on. So I don't see it, at least at the moment, I don't see it something that it's like it would break the system if we have some sort of outage on that part. When it comes to energy, I think we have, at least when sitting in Finland, we have one of the best energy networks. So we have a really reliable grid that is a little bit changing depending on where you're located. Most of the automation systems are backed up by UPS systems, at least, so that you cannot continue maybe to operate the system, but we can have a controlled way of running down the system. And I think that is more and more the trend also in the future and in the discussions with the customer, that we have to have a controlled way of running down the system if there is a power outage.
Great. We have a 3-figure number of audience here, and I know that in few universities you are seeing these presentations there in a classroom or lecturing room. You can also raise hand who are here online, or if there is some student, some teacher with number of students, please raise your hand if you like to ask or comment. So we have a good opportunity now to ask from really professional. Lauri knows lots of automation and what the warehouse of the future should and could like. So no any hands yet, but please use this opportunity if you like. I think, Lauri, that you had a very nice overview or let's say conceptual picture what is included in a current warehouse. You started from manual storage up to automated conveyors, shuttles, and so on to be organized through software you called WAMAS. But you had there between manual warehouse and full automation, you had a word semi-automation. I really like this term, or let's say like they say there in Logisnext, for example, mixed fleet or optimal automation. Would you like to comment your thinking related to semi-automation? Why we need something there in between?
I think it's essentially kind of a scaling issue or background. When you're starting from a very small warehouse, you can of course operate it fully manually, but there is a gap from running. Let's say that you have you are selling, you find your own business and you're selling parts for bikes. You have one garage of parts. So of course you can just have manual shelving there and you have the parts there on your storage, and then when somebody orders something, you ship them. Then we go in this really big scale of Amazon or this big clothing retailers, Zalando or whatever. These are the magnitude is so huge that it would be impossible to handle those volumes purely on manual labor. But then there's those like in between companies who are already growing and the scale is getting quite big, but it's still not feasible to invest in like a fully automated solution. So we have a lot of that type of companies in Finland, and we really work with a lot of companies in this with this type of semi-automated solutions where we integrate, for example, these vertical lift machines, where it's not a fully automated storage system, but it is something in between that helps the customers already a lot with space efficiency and also the picking efficiency, and the implementation speed is much quicker, and the implementation costs are also much lower than like a fully automated system. So it's really a bridge kind of from that manual warehouse to that fully automated warehouse.
Okay, so you see it more like a let's say continuum between, let's say, developing company as well as existing large scale company. We have here a question on the chat: how much and what kind of data is collected in the process and how it is handled?
Now, in the process of what?
This might relate to warehousing process from receiving to dispatch. So you presented how to receive materials, how to storage them, then up to picking and dispatching. So I believe this relates to the warehousing process.
That's a really hard question to answer. How much data is collected, because that depends fully on the customer, how they are, like if we're talking about, if we start from receiving products into a warehouse, there's different information that different customers require to collect. If you're in pharma business, you are required to collect a lot more information than if you're just running that your own bike storage in your garage. So it's quite hard to give an answer to like what or how much data is collected. I would say, yeah, just purely all in all, I think when it comes to data, there is a huge bunch of data available in any business, any sort of, if it's automated warehouse or even a manual warehouse, you can collect a lot of data. And I think in Finland, we started at least maybe 10 years ago, companies really started to talk more about data and that we need to collect data. The companies that are really standing out now are, from my opinion, they're the companies who also started to think, how do we use this data? Because there's a lot of companies in Finland also who collect a lot of data, but they don't really use it to improve their processes or improve how they work in the warehouse. So yeah, I guess I'm not really answering the question, but it's really difficult to say what data is collected because it depends so much on the individual company.
Yes, but thank you for opening this issue also a little further. I believe there still exists number of interesting issues we can discuss based on your presentation, but due to the time or schedule today, I believe that it could be good opportunity now to move from Lauri's presentation to next one. You raised, Lauri, for example, e-commerce a lot. We believe that the next presentation might also include it, but Timo from Konecranes has set the topic as a development of production logistics. We also know that you have a number of references, and we saw that you have also a number of references there in production logistics side. But maybe after Timo's presentation, we have opportunities to try to compare a little bit those trends and challenges you raised up there in e-commerce side with Timo's thoughts concerning the development of production logistics. But thank you, Lauri, on this stage. Hope that this discussion will continue, and at least I would like to summarize and comment few points there in the latter part of this webinar.
Thank you.
Thanks a lot. So let's go into the next presentation. We will have the next speaker from Konecranes, Timo Husso, and he would like to present his thoughts concerning the development of production logistics. Please go further, Timo.
Okay, good morning, everyone. Also from my behalf. Just a second. So like Heikki said in the beginning, I will be focusing mostly on the production logistics and especially on the assembly side of it. And I'm also focusing on, I would say, that our current offering on what we are able to provide to the industry as Konecranes at the moment, but also where we are developing the solution towards to. Shortly about myself, so Timo Husso, leading our sales and account management for Konecranes Agilon warehouse automation business. At the moment, we're focusing within my team, especially for Finland and UK. A few customers also in Sweden, Germany, Netherlands. So mainly on the Europe side where we are focusing at the moment. But corporation itself is obviously much bigger. About my background, from the educational point of view, I can relate to Lauri as well that it has been a continuous learning path from my behalf as well. Bachelor of Science from Telematics for Logistics Engineering in 2004, if I remember correctly, and Master of Science for Knowledge Management in Industrial Engineering from Lappeenranta University of Technology 2013. And as you can guess, that particular education was done by full-time working also. So it's a continuous learning path which I strongly recommend for everyone. We are never ready from the learning point of view. Konecranes as a corporation, how is basically the company? We can say that we are the global leader in material handling solutions. As the name of the corporation is stating, you most likely connect us to industrial cranes especially. there's few examples of the customer environments what you can see from this slide. From huge harbor operations, which can be nowadays fully automated, so there's basically no human labor involved in this size of harbors, to industrial environment where we have even a small or mid-size company which uses individual lifting devices. And the not so well-known part is obviously the warehouse automation, which I will be giving you further insights soon. Quickly, some background of the development of the company itself. Originally, Konecranes was part of Kone Corporation, which you most likely know from the elevators and this equipment nowadays. It was a division of crane business within Kone Corporation. Since early 90s, it separated as a totally separate company. That at that point of time, the leadership of that division made the acquisition and established a separate company. And since the early 90s, the company has grown a lot, both organically, but also especially by doing acquisitions. And as you can have seen a few different attempts to make mergers as well, we have been in that path as well. But also as a result of the attempt to make a merger, we have received significant growth on individual businesses like the port solutions, but also within this acquisition part we got knowledge and solutions for warehouse management systems, which can be used on harbor environment, but also solutions which can be used within the industrial environment of manufacturing companies. Corporation is divided to three different business areas: industrial service, industrial equipment, and port solutions. So obviously the port solutions focuses purely on the port side. Basically, most of the biggest harbors and ports throughout the world use some of our equipment. So we are within the top three, I believe, at the moment on that side. And industrial equipment, the cranes, the range vary from the very light lifting devices all the way to heavy industry usage, like process industries where raw steel is being handled, or paper mills, paper rolls, materials such as those. Targets for the corporation at the moment, as you can see on the right side, that where we are as a corporation targeting for. Warehouse automation itself, just to notice that we are within industrial equipment within this business area. Some numbers of the company. We are active in 50 countries at the moment, roughly. The share of the turnover between equipment, so sales of new equipment, and our service is the 60% of the turnover comes from or total sales comes from the equipment. Worldwide, operating almost 17,000 employees at the moment, and the regional share, as you can see, the EMEA area is 60%, and Americas and APAC area there 20 each. Then if we look different industries where our solutions are being used to or used in, the variety you can see from here. Logistics is a big part of it, and obviously the port side is taking a huge consumption of it. Then another point from this graph, what I would highlight is this general manufacturing. It's basically an industry, name of the industry what we use at Konecranes, but in real life it consists of several subcategories, as for example electrics industry, as one example. Okay, then to the more specific solution on for today's agenda. The warehouse automation in more specific Agilon. This particular solution, what you can see at the moment from this slide, has been existing and developed within the first years since 2012 when we launched the sales in Finland. And within, I would say, the 3 years from the start, this setup was existing. So basically, the system itself, what it looks roughly, it's a modular warehouse automation system. So this physical system actually exists on the customer's premises. Then we also provide a web portal for the customer, so software support to manage the data. Typically, most of the systems are integrated to customers' ERP systems or warehouse management systems. And in the beginning, the solution was mainly focused for maintenance operations, for maintenance warehouse or technical warehouse, which is a kind of a synonym for the very same point of usage, especially on well, for example, UK uses that terminology more often as the maintenance operations. And for that particular reason, these supplier integrations are mainly focusing on MRO, so maintenance repair operations side. So basically, this particular side is providing automatic replenishment orders and support for consignment stock for the end customer to manage several customers' materials within the same system. But that basically it's roughly the setup for the maintenance operations itself. But when we come to production logistics, there's several building blocks what we are able to use for that purpose as well. The modularity of the system and the capabilities for scaling that to the production logistics usage is also or have been existing there as well. Global technical support we have as well or have been having from the very beginning. Remotely supported systems, over 80% of the tasks can be handled remotely. Predictive maintenance have been the core setup from the beginning. As Lauri mentioned, that I also can fully agree on that the predictive maintenance and the maintenance itself definitely needs to be within the actual usage of each component. It can't be within the fixed intervals. So that's I would say that nowadays quite common approach for managing the maintenance. Local field service, we are utilizing obviously our existing global network of field service. The same personnel who are managing the cranes or within the port side, the port equipment as well. They can be teach to do the installations of the warehouse automation systems and also covering the field service, doing the technical service of the systems as well. Okay, then for how we have been developing the system, well, just a quick note on that one, that you can see from here that the system specific technicalities is that there are robotics also in here. So it's not a shuttle system, it's not a vertical lift system either, but it's more, I would say that the more closer is a shuttle system or a cubic system like AutoStore. So it consists of several robots within the system, which can move diagonally inside of the box, if you would like to use that term. Basically 2022 we started quite heavily investing on the technology development on the production logistics side, but also to be able to match the competition and go even beyond in some areas to focus on production logistics especially. And there were a few features which we started first to implement, which were kind of already existing in the market. So pick to light, put to light, batch picking, those have been implemented in 2023. Multi-item box, basically within one box you are able to manage several SKUs or optimize the space usage, and also to provide in certain applications support for picking certain sets, ready-made sets to the production. And then for the next step was to enhance these to tend to be able to work combinedly. So batch picking with the support of put to light and pick to light was the next step. Same thing with these multi-item boxes. Last year we delivered the first solutions for the conveyor output, so automated handling instead of manual handling. So this traditional user access point was designed for human usage, and for the output conveyor we are able to fully automate the material flow. Taller warehouses to make the systems even taller, and then as the last thing what we launched in UK late last autumn in the International Material Handling Expo was this Autoload trolley. But I will go into more detail on these ones a bit later on. And then you can see a bit what we are working on at the moment, and we basically, the reason why I'm giving you this information already is that there are such systems which we are delivering within few months, but also which are under development, but we are selling as well already. But the basic thing here is that these are the kind of core topics where we are focusing on the solution development, or have been since 2023 mainly, for to develop that even further. Okay, from those features, just to get some understanding on the actual customer environments, that how these functionalities can be used in actual customer environment. First implementation couple of years ago, what we did with this batch picking. Well, first of all, batch picking from the terminology point of view, you basically select individual, for example, in this particular scenario, you select individual production orders and combine them as a one bigger combined picking list. So those materials are being picked at once, and typically that benefit on this way of working is that, especially if within those individual production orders you have same SKUs existing, then instead of picking one for per production order and doing it several times, we are eliminating this multiple times picking the same material, but instead just picking it once and then dividing it in separate production orders again. Pick to light and put to light, as you could see from the video of what Lauri showed, it's quite common, and I would say that as a technology has been used for decades in the industrial setup. But it's still, and I would say that it will remain still quite evident part of providing efficient support to avoid errors, to easily guide new personnel to do their work, but also on day-to-day operations to be able to efficiently pick materials or put the materials into selected locations. This implementation we did to our own hoist factory. So we are talking about light lifting devices located in Wetter in Germany. There's four. We basically assemble light hoists of four different brands. So there one brand of the hoist is Konecranes, but then there are also other brands. So we have also these sub-brands within the corporation. And there's four different production lines after this particular picking area, what you can see from this illustration here. System is integrated into SAP. The whole project, what we did was together with our internal logistics specialists whose day job is basically improving the logistics processes within Konecranes factory throughout the world. But also we used few external experts on the logistics development side as well. And the end result was to totally renew the layout of the factory logistics, including the bigger parts, storage, or I would say buffer stock, and what supermarket, I would say that it is the best terminology for this particular area. But the bigger materials and also the small goods handling as well. And let's look on I'm not sure about the voice itself, that are you able to hear the voice, but I will show the video itself. Video can be found from our website, so I believe Heikki, we are able to provide some web links for you as well. Okay. So as you could see that maybe just one additional thing which you probably could see from the video quickly, that there was a big screen here at the end of these shelves, and one point of noticing is also that together with the actual automated warehouse, we also manage by software the whole area of these shelves. So we basically know from the software side that which materials are in which locations and where it should be picked, and basically the full integration with SAP is done in such way that when the logistics worker is picking those small goods first from these shelves on that side before moving to the bigger materials, every individual pick is automatically confirmed on the SAP side, and in that kind of way we are eliminating those basically unnecessary manual steps to record any transaction on the internal material movements within the factory. Another example from Finland, ABB Distribution Solutions in Vaasa. That's the current solution, what they're using. What we did, this was done a few years ago already. The thing there here is that they were started to use parallel picking and also batch picking, and this is used for buffer stock for ready-made products as or kind of semi-finished goods, in that sense that those are being moved into the assembly cell. And in this scenario, they are using pick to light or put to light tables, which are basically electronic tables. You are able to select the height based on the height of the user to be more economic on that sense. And materials are moved after picking. They are being moved automatically by using AMRs, so automated mobile robotics. We have a video about this one, but let's not check that one on this stage. I will also provide a web link afterwards on that part. Then the next topic, integrated material flow. We made a study, and we have been studying this, as you can imagine, quite a lot during the years, on that how Agilon could be embedded even further into the individual steps of the production logistics. There's, if you look on this part here, is that there's quite simplified description of individual steps of the production logistics within the factory, for starting from the goods unloading from the truck to goods receiving, then the material put away to stock, so moving the goods from the goods reception area to the stock location, some intermediary warehousing, and then will be the point of first time picking from that warehouse. Obviously, it's totally depending on the customer's industry, the size of the company, what kind of volumes do they have, is that what is the actual what are the actual process steps after this part? Are there sub assemblies? Is it a cell assembly, cell production type of operations, or is it for example, if I go to vehicle industry, is it the production line type of operations? All of these aspects are giving also certain limitations and requirements as well for the design that the production logistics around the production itself. But the study what we made basically is that how we are able to utilize Agilon is in more depth and integrated to the production itself, instead of being just a kind of just a automated warehouse, which is not have any proper connection to the production itself. And already from the early years, we identified that the potential for the inbound and outbound. Here we use the term of feeder, but basically outbound conveyor access point for to automatically feed the materials within the automated warehouse and also retrieve the materials. Based on the study, what we noticed that the most suitable way is the mobile robotics nowadays within the current applications. They are definitely places and usage for the conveyors as well, and that will remain also in the near future. So I personally don't see that the conveyors will be disappearing totally in the near future. There are certain places where they are obviously needed, and that's the case in our point of view as well, if we look our offering. But then if we think about the internal transfers, and especially when I'm talking about production logistics, where the end customer is building industrial products, maybe more on the B2B side, business to business, instead of business to consumer side. The mobile robotics is definitely an emerging, and it has been several implementations, for example, in Finland, have been done during the recent years. And the reason for that is that obviously the robotics themselves are becoming more cost efficient, and also that if we compare to conveyors, for example, in this scenario, is that they are much more flexible. They are not taking the floor space as a kind of fixed floor space and creating limitations for the layout design in that aspect. Let's see how this short simulation works, since there's a lot of you on the line, but nevertheless, let's look. It's, as you can see, that it's a bit speeded up as well. Here's an illustration of what the system can look like in the near future. And then what kind of elements we have designed for the system. All of what you can see are actually, they are not like developed by R&D professionals only, so there's a clear customer demand. This individual parts, what you can see here, are based on actual customer projects, what we have been and are at the moment working on with the customers. So that the level of automation is increasing, obviously, and there where we are still needing human labor, it's obviously that the question is that what is the throughput required? That is it more beneficial for the end customer to use human labor on the picking side, for example, or is it also handled by robotics, like in this case? So in this particular illustration, there's, for example, that inbound movement, the put away to the warehouse is done automatically on that side, and then this particular area is done for kind of mixed boxes consisting of several different SKUs. And then here, as the last part, the robot is taking care of doing mixed palletization. So that packing to come back to the pallet size of packaging, then that can be done automatically instead of manual labor. Okay, a few examples about integrations with mobile robotics. Well, now I'm coming back to those individual features a bit, what I shortly showed you in the beginning. Output and actually also input conveyors. The core module is the same. We are able to move turn the direction to the other side as well. So the same kind of module is being used to both directions. But the core thing here is that we want to be and remain independent on the connection itself. So meaning that the mobile robotics, mobile robotics or AGV or what is taking the materials out from here. Okay, it can be provided via Konecranes, but also in some of the customers, they already use AMRs for some other purpose, or they have a good connection, for example, with the existing partner who is able to provide that kind of equipment. Then the main thing is that we are able to integrate the conveyor easily with the next equipment what will be moving the materials within. There's an example about an AMR from one customer, so it can look like this. Boxes can be picked into several locations. Another example is this one, what we are basically selling ourselves. It's manufactured by Bito, a German manufacturer of AGVs, and especially you might know them from other warehouse equipment like shelves, boxes, very known in automotive industry for as a manufacturer of KLT boxes, which are heavily used on warehouse automation. Then this mixed palletizing, that's another example here. And as you can see, there's an ABB, AGV moving materials. Robot can be whatever, basically. So there's a system integration done between Agilon and that particular manufacturer of the robot, so that the systems make the handshake in what we can use as a term on that one. Latest feature what we showcased in UK was this Autoload trolley. Actually, I jumped to this one first. This is how it looks like when within the system itself within Agilon. So there's this docking station within the system where this trolleys can be docked into. And the thing here is that instead of, if you remember that the traditional access point or the output conveyor, boxes come one by one and then they are being moved further to the next step of the process. But in this case, the robot is able, or robots are able to fill in several boxes within the one trolley, or naturally empty the trolley as well. And then when the required materials are being fed into the trolley is being moved to the next phase to the production. As you can see, that there's quite a many potential applications for this usage. So it can be from the very start of the inbound logistics. So from the goods reception area to be made as a put away for the small goods, but it can also be used for supporting the set making in production, and several others. as well. And let's see, this is also rough illustration on that from the good reception area to the stock and then the next, and then to the next phase as well. So the good reception and the filling in can be done manually, but it can be done naturally automatically as well. And here what I meant with rough illustration, that you could see that the robots were not passing each other in this visualization. But okay, that was the put away part of it. From the design point of view, we took into account that the customer's requirement, that based on the customer's situation at that particular point of moment, it might not be feasible to fully automate the process. Manual handling might be still a viable option in the beginning for a couple of years, for example. But from the design point of view, we wanted to take into account that the level of automation can be increased when the time comes in all of those customers who are taking this solution into use. So manual operation is totally doable with mobile robotics. So it can be a big solution like this. Also, we are talking about automated forklift truck, but it can be an AMR, what you most likely have seen some solutions where basically the AMR is just a very small, just covering the footprint and lifting what needs to be lifted from the bottom, and that's basically the AMR, individual AMR itself. So it can be a huge one and can be a smaller one. And there's another example about even bigger. Okay, about this inbound logistics, how we see that basically generally the inbound materials or SKUs can be divided roughly into 3 different categories. We're talking about small goods, and why we limit that to 25 kilograms is basically coming from the law. If the material weight goes above that one, by the law, person can't lift that by just muscle force. It needs to have some lifting device to handle those boxes. We can provide solution for that purpose, obviously, but categorization is that these are such which can be handled with human labor if necessary. Then we talk about pallet size materials, and then also the heavy materials which goes above what individual pallet can handle. And with this autoload trolley solution, we are focusing obviously with the small goods. Automated production. So here we have an illustration of an automated production cell. Maybe this shows a bit better on that one. That there's docking stations on the trolleys where materials are being picked from. It can be fully automated, so a robot is able to move, for example, here to pick materials from each of the trolleys and fed here to the actual production. Production or also sub-assembly or end product assembly can be fully automated, depending obviously on the product itself. But if we are talking about smaller goods, it can be clearly automated. And then final packaging as well can be done, and then also fed again to the trolleys, and the trolleys can be then automatically moved to the dispatch area ready to be shipped. Okay, picking stations, maybe not that much new, just an illustration, but the main thing here is that we rely also quite heavily still on the usage of the pick to light, put to light displays. We see that it's still a viable option to provide efficient operations for the customer. Set making or kitting part of production. As you can see, like I mentioned, the conveyors are here also used. So we see that there's definitely a purpose, and they are able to provide efficient way of working in certain steps of the production logistics still. Bigger illustration what can be done, but those are like individual parts on where automation can be used and how scale and level of automation can be increased in the production logistics. As the last thing, what I wanted to highlight that how we see that what can be expected from the future of intralogistics in production is that the level of automation will continue to increase. Basically, there's two things on that side, that the solutions are becoming more cost efficient. They are obviously developing all the time, but also that the monotonous work, there's still plenty of room for improvement on that side. At the moment we are seeing the first implementations also on the actual assembly work. An individual assembly of a product can be fully automated with robotics, and then that's obviously decreasing the need for manual human labor. Another parts of the logistics itself is bulk kitting, packing, unpacking, individual material transfers, and how I can see also that the actual development work, if we think about the engineers of who are thinking of how the intralogistics needs to be done and what development needs to be done for that within the factory. That at certain level can be automated. I'm not meaning the full automation, but it's more about usage of AI itself, so that the tools and methods are becoming more enhanced on that side, and that the available data can be collected more automatically. Also that the usage of automation supports that side as well. And if we think about the individual design on how materials are being moved from the supplier to the factory all the way to the usage location, that path can be designed more and more automatically in the near future. From warehouse automation point of view, how we see that these kind of systems will rule within the market. Obviously, all systems have a certain limitation from the capacity point of view, but the thing there is that what after that is that the systems solution provider able to develop the solution further to meet the requirements of the end customer. That is can the system be scaled to bigger from the point of the performance point of view, the transaction capacity, but also from the warehouse space point of view, that if there's simply a need for more space, there's a bigger amount of SKUs needed to be buffer stocked as well. The flexibility, how the system can be changed when the changes are needed. When there's a change for the of the layout of the production itself, that the actual production process needs to be changed, then the supporting logistics processes needs to be changed as well. Methods and the location in the bigger picture, if there's, for example, a change for another location, how existing equipment can be used and further developed on that scenario. Connectivity, it's simply a must for to provide a seamless support and full scale solution for the customer. Thank you. And maybe back to you, Heikki, now and some questions.
Thanks a lot, Timo, also for your excellent presentation and lots of technologies there, but not only technologies, but why and how to put or integrate them together. I think that your last point, connectivity, relates to issue Lauri already raised up, how to integrate or how to have this systems thinking there. We have already a number of questions here on the chat. Thanks also, Lauri, for answering few of them. If I raise the first one here for you, Timo, in the Agilon, how can we minimize or optimize the total movement inside the device? So there is a longer question, but if you optimize or get these internal movements, minimize it or optimize it, this is causing less energy consumption and so on, and requiring less maintenance and so on. So how are you optimizing this one? And actually there is another question related to partly to the same issue. Are you able to use standardized boxes or what kind of boxes you can use there to optimize the space utilization? So how to optimize space and movements, space utilization and movements there inside Agilon?
Okay, two questions.
Yes.
The internal movement of the system itself, I didn't basically go into detail on the latest development, but we are working on that side to further develop on that side of it. How we are minimizing is that there's, well, the system logic itself is that within milliseconds there's a software calculating different scenarios on how to move the individual box the most efficiently to the stock, into individual stock location inside of the system, or from the stock to the individual picking location. To further develop that side, we don't see that it's not necessarily the target to minimize the individual movements within the warehouse, automated warehouse itself. If we think about how the robots are moving inside of the system, so as long as they are doing wise decisions, and that the capacity is used in the optimal way. Basically, our current development is that we are focusing on to provide more efficiency in that way, that we are able to raise the amount of individual robots. Because basically what you can see from the existing shuttle systems or cubic systems, the core thing how the performance is provided for the operations. The core thing there is that there's several robots doing the job. If we look on the speed on the individual robot, it's actually not that high pace or fast movement itself. But as an end result, from the picking worker point of view, that performance is shown as that the system is fast because of that there's a lot of workforce inside of the system. But obviously from the energy consumption point of view, how we already, I believe, bit separate from the other solution is that we are using office electricity, so Shuko socket instead of three-phase energy. We use the braking energy when the robot is moving downwards and utilize immediately for the next lifting movement, as an example. But obviously this is becoming more and more important topic to minimize the energy consumption. So we are looking further development on the how this can be enhanced. And the other question on the packages, another point how we are a bit different on that side. We have limitations from the for the box. Roughly the maximum was the 25 kilograms for one box. Size point of view, from matchbox size to a moving box size. So we are talking about the 1/4 of a Euro pallet. So 400 millimeters times 600 millimeters is the maximum footprint dimensions, and 450 millimeters on height. So maybe that's about those ones.
Thanks a lot for the questions and for Timo for answering those. We are now running out of our time, so I believe it is good time now to close down this session. I'm very happy and appreciate particularly Lauri and Timo your time and these presentations, and I believe our audience also may benefit from this. As promised, we will provide some material afterwards concerning this event, and I would like to comment there further these excellent presentations, as well as link this into Logistics 5.0 thinking, as well as towards the physical internet. So I believe that when we had these excellent presentations concerning intralogistics, warehousing, production, and so on, we might need to have solutions there on the transportation side to make our supply chains really work. Thank you everyone for joining this event. Hope that you felt this beneficial for you, and let's be in touch in the forthcoming events. I believe our team is interested in to serve all of you. Thanks a lot for being involved in this great webinar. Have a nice day.